Okay, so for this problem, we've been asked to find the amplitude of VI. Amplitude is the peak. So I need to find my I curve and look for the peak. Right there, there's the peak. It is 5. What is my unit? Always remember units. It's given right there as milliamps. Always remember units. If I say it takes me 10 to walk across somewhere, 10 what? 10 minutes, 10 seconds, 10 hours, it means something, right? RMS value of V. I find the peak of V. Here's the V curve. There's the arrow pointing at it. It is 10 is the peak, but I'm asked for the RMS value. Root mean square means I divide that 10 divided by root 2. You could also multiply it by 0.707, and it's in volts. The last thing is back to Eli the Iceman. Is it inductive or capacitive? This one is crossing through 0 before this one. And so I leads E. I leads E or V. It spells ice. It is capacitive. I'll clear this and let's scroll down to the second part. Given the high pass circuit given below, we need to calculate the reactance. Reactance, XC. Where is that on my formula sheet? Here's my formula sheet right here. XC, I'm given the capacitance, I'm given a frequency, I will calculate the XC. XC is equal to 1 over 2 pi F C. 1 over 2 pi, the F is right here, 12K. 12K and 20 nanofarads. 20 nanofarads, I think it comes out to 663 ohms because we're looking at reactance. And now for the gain factor, once again, I can just go straight to the formula sheet and it's down here. The gain factor, be sure to grab the correct one. This is a high pass filter. If it didn't say high pass, I did say it maybe is worth memorizing that the high pass has the capacitor in series, but there's a high pass. We're going to use this equation right here because we have XC and we have R. So I can write a V is equal to 1 over the square root of XC over R squared plus 1. You can plug this in, and I think it does come out to like 0.998. But if I just see that 663 over 12,000, right, that's really small. I think it comes out to like 0.003 plus 1. Essentially, my factor comes out to 1. That's the point. It comes out to 1, and that's because it's a high pass filter. This is a high frequency. And so what happens is that whenever this is 1, this is such a low resistance. 663 is way lower than 12,000. And so there's almost no impedance coming out through here. So it acts as a wire, and then all of the voltage gets to come out. So pretty much all of the 10 volts, or maybe 9.98 of the volts, is allowed to filter through. It's allowed to pass. That's why it's a high pass filter. The high frequency allows it to pass through.